Yeah. Okay. Okay, guys. Let me start. Okay. Good evening, guys. Good evening, one and all. So let me give you a quick introduction about our alumni. Our alumni is Siddhartha. He's from Amazon. He works as a data engineer, guys. So he has almost about 4 years of experience, near about 4 years of experience, and he works totally on cloud. More specifically, he works with Spark. He works with all the like most of the AWS services more specifically, and he works with more specifically when it comes to big data tech stacks. He works more specifically with Hive, and he works more specifically with Spark. So let me tell you one thing. Let me tell you one thing. So Siddhartha joined as an intern in 2019 in Amazon. Actually, he placed via campus recruitment. Once he completed his internship, he joined Amazon as a full-time employee. So let's welcome Siddhartha. Siddhartha, thank you for coming here and uh, thank you for coming and accepting the invitation of Seco Big Data Institute. And I want you to give some quick good insight about you, about yourself, like how what's your experience, like what are the big tech stack you work as a data engineer in your day-to-day life. Just give a quick introduction about you, Siddhartha.
Um, Hey Karthik, yeah, sure. Yeah, thanks for this introduction, and good evening to everybody who whoever has joined. So yeah, it was pleasure being here. So yeah, coming to myself, like as Karthik mentioned, I have been with Amazon like more than 3.5 years. So I joined as an intern, and then after successful completion of my internship, I was serving as a full-time employee there. So yeah, my experience at Amazon so far was super challenging and exciting every day. So, it was almost you leading your own startup. That's how the work culture at Amazon. So every day you face a new challenge or find new ways to solve the problems and all. So yeah, coming to our team and roles and responsibilities of our team and myself are we deal with tax data for Amazon. So our roles and responsibilities include maintaining the data pipelines and maintaining the data quality, and make sure that Amazon is compliant and paying the right taxes to the governments, and not paying the over taxes in fact to the governments, doesn't enter into any compliance risk or doesn't get fined anywhere in any jurisdiction. So maintaining all the local laws and obeying all the global laws. You could have seen like some companies, you know doing a small mistake in European Union, getting fined for 2 billion or 3 billion. So
Exactly.
like that's the space we work. So our data is super critical for Amazon, and yeah
That's good.
yeah, we need to deliver those kind of solutions for Amazon. So
Okay, that's good.
that's most about me.
Ajay, I will try to pick some, like there are some beautiful questions being like it was picked from the audience actually. So let me go on with one by one question, Siddhartha. I think you will give some good and give some good insights on that question. So can you tell us about how your background, how you become a data engineer at Amazon, basically? Like,
So yeah, coming to my part, may not be super helpful for everybody here, because I'm a campus hire. So I was in my final year when Amazon came to my campus. So I was actually more inclined towards ST. But as opportunity comes your way, it's all
okay,
like how you pick it up. So
okay,
then after joining Amazon as a DE, you know, I was more inclined towards data engineering, because earlier to that I was, um, now not maybe too much of knowledgeable about data engineering space. So yeah, once joined Amazon and start working on data centric projects, contributing as an intern, that that gave me a good excitement. So then I decided that I could be a data engineer as well. May not be a super STE, but yeah, I'm enjoying. I, I'm happy for the decision, and I'm enjoying my work at Amazon. So yeah, mine was actually campus placement, but if anybody wants to try for Amazon, so I would recommend the tech stack should be solid. So there would be based on your experience. Currently, the hiring has frozen. Sorry if anybody was trying right away, but maybe once the times are back to normal. When hiring opens, you should be super solid on SQL. So which is basic for any data engineering role at Amazon. And on top of that, yeah, adding cherries to your cake would always be super good. If you can have Spark, like all big data is moving towards Spark, and having a bit of exposure to cloud would always add additional advantage.
Additional. Yeah, that's cool. So let me move with second question, Siddhartha. So, like, what are the key skills and knowledge that you think are important for a data engineer to have, especially when working at Amazon?
Okay,
Apart
good
from that,
question.
like a skill. Yeah.
Yeah, yeah. So key skills and knowledge that you think are important for a data engineer. Um, so especially working at Amazon, you had to deal with like huge scale of data. When I say huge, like you don't even get that much of big data sets outside anywhere, because
Okay.
right, how many billions of orders Amazon ships over a day.
Yeah.
So it's simple, like maybe an intern coming in and start working on a table which has 1,000 columns and 135 billion records starting day one. So it would
Oh.
be like super huge that you can't imagine the scale at which Amazon is growing and handling the data. So when the data is too huge, uh, the important, the super important skills that I assume you should be having is understanding the data. Maybe you will never be able to identify and index what are the 1,000 columns on the data set, but
Okay.
you should have an understanding of at least the key columns based on what your reporting or pipeline depends, and you should be able to identify like you should be sample the data well and build your code around it so that you can model it for high scalability code. So when it comes to
Okay.
sampling and understanding data is very very important before writing the code. I would suggest understanding is one important thing. And coming to tech stack, like tech stack is changing day by day. So the more updated you are, the more valuable resource you will be. So I would
Okay.
suggest Spark. Spark has um, you know like a lot
Good.
of advantages in handling these huge volumes of distributed system. So Spark would
Yeah.
be a key thing. And working inside Amazon, it is very very important to have good touch on AWS. So without
Okay.
AWS, you will be nothing inside Amazon, because uh, anything that you implement or anything that you need to go forward is you'll end up working on AWS only. So any tech stack
Okay.
that you are picking, you should be strong with the AWS code.
AWS.
Yeah.
Okay. Okay. That's cool answer, Siddhartha. Thanks for the insight. So let me move with third question. So how do you approach data architecture and design when working on large scalable project more specifically?
Yeah. So data architecture and design. So maybe uh, the basic part, I mean, which is expected when you are trying to design an architecture or propose a data model is you should be strong at the basics of all the existing data models first. Whether Snowflake schema, star
Okay.
schema, like however dimensional modeling works today. So when it comes to large scale, uh, there is no straightforward decision or no straightforward answer that this model will suit us better.
Okay.
Because uh, like in a dynamic environment like Amazon, maybe I'll just give a short example where a customer who has purchased a product 3 years back can now come in and put a comment over there or
Okay.
give a rating to that. So that's where your architecture becomes much more trickier than any other data lake. So nowadays, like uh, maintaining the delta is also becoming very very important. Like the delta lake or hoodie, which are
Okay.
coming into the part of big data, those should definitely be considered designing. And one more important factor that I would look at while architecting or designing, like what kind of a data warehouse or data architecture or data model that you are building in. So you want
Mhm.
to have good performance while reading. For example, if you're dumping a million records on a daily basis and reading 1 billion records on a daily basis, so your model should be strong in such a way that readability should be, giving good amount of throughput. So that's where you
Okay.
need to choose the tools and technologies wisely, because you have a lot of options again, designing on EMR. You have, sorry, on AWS, you have EMR, you have Redshift, you have Glue, like whatnot. So it's always the problem driven design. What kind of a outcome that you are looking for will always, continuously evolve your design. And this cannot be done in a single iteration for sure. It's always a
Okay.
learning. You fail, you learn, and you redesign your architecture. Maybe you release 2.0, 3.0, and it'll saturate at some point with all the learnings that you are going.
Okay. That's cool. So let me move forward with fourth question, Siddhartha.
Sure.
Yeah. Like, can you share some of the biggest challenges you have faced as a data engineer at Amazon, and how you
Uh,
overcame them actually?
yeah. So the biggest challenge, maybe I could talk about the challenge that we come across last week. So I'll give a typical example of a data scenario where a Redshift table
Okay.
has like 1500 columns, which is
Yeah.
used for taxation of some other country. I don't want to mention. Which has 1500 columns and 140 billion records. So there would be a daily updates to that table that are coming in. So you need to scan that 135 or 140 billion records, and need to update a flag wherever applicable. So this is one challenging part wherein we have a vast Redshift cluster of 68 nodes of RA3 type, which is one of the huge clusters in Amazon itself, and we are still running on 4.5 hours of runtime to update this table. So that was
Oh.
the biggest challenge raised by the team, business team, that you need to reduce this time frame from at least by 50%. So that's
Okay.
where again everything. I mean, the understanding of data will drive you to the solution always. So the same. So
Exactly.
Redshift has all these concepts like sort key and distributed key, which were already being applied. So then on top of that, you need to think more. You need to understand better your data, and you need to define a proper distribution key again. You need to play around with the combinations, like what suits best for your configuration that you have on premise, and what part of the data you wanted to make hot and cold in Redshift, and a part of it you wanted to put in on S3, and maybe incremental processing. So this is what we all explored, and we came up with a solution like that. 4 hours got reduced to 2.5 hours precisely now, but business is still not happy. They wanted to reduce further, so we're still working on it. So, yeah, maybe one of the challenge we recently have. Like, can we have any? So I think that example would define the scale of Amazon. I think Karthik, you're on mute.
Okay. Thank you. Thank you for your answer. So let me move on with fifth question. So can you provide us a brief overview of AWS services that you use in day-to-day activities? How you use them? More specifically, whether you use AWS EMR or AWS Glue, Redshift, Athena. So could
Mhm.
you give that good idea?
Yeah. We
Yeah.
use many AWS services. Maybe every
Okay.
Amazon guys are more conversant with AWS services. Like, we use S3 obviously to store our
Okay.
last 10 years of data. And to talk precisely about S3, we use different storage classes in S3. I think
Okay.
people who knows S3 might be aware of it. Like, we have cold storage, maybe simply calling it as a cold storage, but Glacier, readily accessible, intelligent tiring. So there are a lot of ways. So based on your
Okay.
requirement, we use that storage classes in S3. We use EMR obviously to manage heavy workloads that usually have. I mean, to churn up the tables that usually have 1 billion records a day. Our EMR scale can go up to. I mean, we always tend to. I mean, in our team, we always tend to use like R4, R5, R6 type of clusters with around like
Okay.
20 to 75. Maybe being at
Mhm.
Amazon, we are not too much worried on the cost of EMR. So we always
Mhm. Use
strive for
whatever
the
you want.
yeah,
Okay.
yeah.
Okay.
We
That's cool.
always strive for that. strive for the performance. Maybe that's where our EMR use case comes. So yeah, and Glue, like being very, what I would say, developer friendly. You need not maintain too much of pipelines. You need not maintain any infrastructure for Glue and all. So that's where for any simple workloads, maybe copying one file from this location to the other location, just loading one table from another table, making a deep copy. All these kinds of
Okay.
stuff we'll put them on Glue ETL. AWS Redshift, obviously, Redshift is one of the flagship products for Amazon in data engineering space. Like whenever you have like petabyte scale data and you wanted to read, publish reports to integrate with, and also being providing ODBC connector and Postgres connectors, it is very integratable with all those services inside Amazon. So if you wanted to populate
Okay.
some dashboards, all those stuff, like we are more tend to use Redshift. And recently Redshift serverless to scale infinitely without worried about billing. And AWS Athena, like whenever we wanted to provide our users with ability to perform some tax analysis with ad hoc querying support, we go to Athena. There are other services as well, like we use maybe AWS Lake Formation to sharing data from one account to another account, or making the data centralized and compute distributed over the accounts or regions. And cloud formation, more importantly, to deploy all our pipelines and maintain the cloud, CDK pipelines. Maybe there are a lot of services. We use a bit of DynamoDB, QuickSight, whatnot. Yeah, almost IAM
Okay.
again are managing all these permissions, obviously.
Yeah, obviously.
Yeah.
Okay, that was a cool answer, Siddharth. Let me move with sixth question. And the sixth question is, like, how do you approach data quality and validation when you are using these services, more specifically, to ensure that data is accurate and reliable? Like, how you do that?
Right. Yeah, this is very interesting use case everywhere with the volumes of data that we are working in. So we cannot simply assure that when your job completes, you are done, because we see like a lot of interim challenges. A flow that is loading only 0 records even after running for 4 or 5 hours, or maybe a day's flow is getting skipped. So that's where like we monitor all our flows using CloudWatch for sure. And any abnormalities, like we mostly tend to do a standard deviation from the last, what is a monthly data, last 12 months, 13 months of data, and see that how the record count is coming. If anything suspicious, we will raise an alarm, and there would be an internal monitoring portal for all these to capture those alarms and make sure that you are doing good over the time. And most importantly, uh, at the end of the day, depends on the flow that we design. We have the data sets. Maybe we can call it as data quality profiling. Those will, provide some metrics to QuickSight dashboards to make sure that, hey, this table has loaded this many record counts today, and this is a trend over the year. So you could see all those things. And recently we started using Glue Data Brew.
Okay.
Maybe anybody is aware or not, but Glue Data Brew is like it can profile all your data set and recommend the rules. It underlying uses AWS DQ, which is an open source framework for data profiling and setting up a validation rules. So it's an engine developed on top of that, where you can set your custom rules and make sure, hey, this column should never be null, and this column should always be greater than 10. So these kind of rules also you can set, and if any rule fails, it can halt the process in between. Or if you want to set a priority to the rule, if it is low priority rule, you can still continue further. So all these mechanisms are coming in, and recently Glue also launched inbuilt data validation for the tables that are getting created. So also we are exploring. But yeah, data validation is very key metric that we look at to make sure that we are having accurate
Data.
reporting.
Exactly. Okay, that was a cool answer there. So let me move on with the seventh question. So how do you use Amazon EMR in your data? Basically, what am like, and how you use Amazon EMR? That's the very first question. And second question was like, how like what amount of raw data is being processed with the same, like with using EMR more specifically.
So how do you use EMR? So in what context? Is it like how you spin up and
Yeah, spin up. Yeah,
use
spin
an
up.
EMR?
Yeah.
Yeah. So yeah, for spinning up EMR, like there is no standard. Basically speaking, I mean, if your team is defining one standard, that is well and good. But there are some internal products which offer, a centralized place where you can go and schedule the jobs. It will offer common common pool of resources to spin up EMR, and it works on both ways. Like it can work in BYOC, bring in bring your own compute and do the processing, or else it can be done in some common AWS accounts and will be billed across accordingly to your team. So there are
Yeah.
multiple ways, but coming to our team, so we have again written some scripts in Python and created some Python operators for Airflow. So Airflow
Okay.
is our orchestrator. So wherein,
Exactly.
yeah, whenever there is a load based on some SNS notification or event trigger, so we'll
Okay.
call the Airflow operator that will in turn create our EMR with the set configuration. This is one way of using EMR at our side.
EMR.
And there are some common tools at Amazon where you can just configure and link your account. So based on your configuration, it can spin up and fire your Spark job, Shell job, like whatever you have. That is one part. And what amount of data that is being processed with the same. It's not always with the amount of data that we choose EMR. It's not like that. It depends on the use case, like where you are reading the data from. For example, if you are reading too much of a data from S3 or maybe other AWS account of your upstream that is publishing
Okay.
into some common services internal to Amazon, you'll definitely go with EMR. But if it is too much of a Redshift kind of thing and all, we may not choose EMR even though like the volume is heavy. We might rely on
Okay.
some other compute. Yeah.
Yeah, that's cool answer. So let me move forward very fastly because I'm
Okay.
taking almost time. So uh, so let me ask a very last question. So data engineering is rapidly evolving, right? So what do you think one should mandatory learn which tool specifically if they are currently appearing for interviews in terms of AWS more specifically?
Okay. So I
Yeah.
guess maybe there are some of the folks who might be more experienced than me in this call. I assume. But yeah, to my best knowledge, like whatever I have worked so far, because this is my one and only company, and I just have experience of 3 years. But looking at the space and what I understand so far, yes, it's evolving super fast, and mandatory tool to learn. I may not be suggesting any tool, but I would definitely recommend people to look at cloud and maybe get exposure with someone's echo is coming up. Maybe get
Yeah.
exposure with at least one cloud platform. Either it may be AWS, Azure, or GCP. So getting that exposure on cloud and at the same time optimizing your job much better is one more important factor that is coming in. Like for example, if you look at the Spark jobs, maybe like a lot of the engineers can write the Spark code or the Spark jobs. But if you look at the trend in the interview questions, so mostly it is like they'll give you, typical scenarios like you have a 200 GB file, two executors, and five drivers. How you distribute your load and retrieve the result more effectively. So yeah, Spark is always currently the hard cake in data engineering space. On top of that, if you have any cloud experience, that would be a good add-on. And having said that, SQL should always be pursued as a first priority if you're stepping into the data world. Like you know, uh, you should be well versed with all those what do you call window functions and advanced SQL stuff to get excel in your interviews. Maybe.
Thank you, thank you, Siddhartha, for giving cool answers. So let me open the questions for the audience. Audience, you can ask whatever the questions you have, and Siddhartha is ready to give the answers. He will give some good insights. So if someone want to unmute and speak, you can unmute and speak. Just one by one. Guys, who are having any doubts, you can unmute and can ask questions. Or else you can drop the question over the chat as well. I can read over it, and Siddhartha will give the answers. Anyone, guys?
Yeah. That's okay.
Hello, I'm audible, guys.
Yeah, you're audible, Karthik.
Yeah.
Not sure whether the audience has any questions.
Okay, sir. So anything doubts?
Anyone, guys? Anyone having any doubts? Yeah, hope so. Someone is unmuting.
Yeah.
Yeah,
Hi,
Navin.
Siddharth and Karthik. I just
Yeah,
want to
yeah.
know what is spinning of EMR. Sometime back, Siddharth was talking about it.
Yeah. So it was nothing but like creating an EMR. So EMR is a service where you can choose your configuration. Like, I want a capacity of 20 EC2 instances, one of them working as a master node and driving the rest of the 19. And again, inside EC2, like there are other flavors of instances where you want to perform memory dense operation or compute dense operations. So there would be a lot of recommendations in choosing the ideal EMR cluster configuration to perform better. So like setting up all this configuration and uh, creating a cluster is what I'm terming as spinning up. Just correct me if I'm wrong. That's the
It's
common
making
use.
sense. Thank you.
Yeah, thank you.
Yeah, that was a cool answer. And there was one more question from the audience, Siddhartha. That he was like Darshan was asking, what is the size of the data that you deal with on a day-to-day basis to compute? Basically, he was asking, like, what is the size of data that you deal with on a day-to-day basis? And I know you touched a bit on it, but could you please elaborate on 140 billion row part more specifically?
Okay. So,
Yeah.
more specifically, you wanted to know what those 140 billion records are. I'm not sure I could give that explanation about that 140 billion.
But you can
But
give that answer in a generic way.
yeah. So like again, as I mentioned, we are working for tax reporting. So right, how tax reporting works. Maybe, for example, if you're filing your income tax or submitting your proofs, you need to have everything that you have done in last 1 year to get that accumulated and get your rental slips or maybe LICs, everything aggregated. In a similar way, if you want to file a tax for company, obeying to that local guidelines, you need to have a lot of data pieces inside it. Maybe a invoice generated by some other team, a shipment sent by some other team, a payment received by some other team, a refund processed by some other team, a customer chargeback where customer coming in, I am not satisfied with product and calling with Amazon and getting a bit of refund. So all these cases will create entries into our upstream data sources. So we need to collide all the team's data to be able to report precisely to the government authorities upon the request. Maybe in case of an audit and all, like it should be super clear picture, like how Amazon received money and how much Amazon is liable for paying taxes, everything. Like as an individual, how we are responsible. Similarly, the companies. So that 140 billion will come into picture. That was a record count for an year for one region inside Amazon. So where those many entries are there in the table, accumulating all these data sources that I mentioned.
Okay. So he was asking one more question also. What is the size of data you deal with on a day-to-day basis?
Yeah, on a day-to-day basis, this is one flow. That 140
Yeah.
billion is our one flow. The rest of the
Okay.
flows are like maybe some of the dimensional tables will also be there, like which generate
Okay.
only 50, 60 records, maybe a bank statement kind of thing. So you'll have
Okay.
like 10, 50 accounts and getting one record for each. So it varies from that's where we use different compute to manage different sizes. But yeah, that 140 billion you could consider as heaviest workflow.
Okay. And there was one more question from Gautam Sagar Reddy. Like he was asking that when do we go with EMR and when to go with Glue actually?
Yeah, good question. So if you look at the configurations of offered by these two products, so coming to Glue, it has some limited configuration. It allows you to choose between two executors, G1.x and G2.x. G2.x is more recommended for memory intense operations where you can perform some machine learning loads and all, and it could limit your compute in Glue. I think they are called as DPU, data processing units, up to 100. In G1.x, you can use for normal loads and regular Python batch processing and all. That would scale up to 250 nodes only. So if your compute and data handling is beyond that, then definitely you will need more compute than which is offered by Glue. That's where we tend to move towards EMR, where everything is custom. You can spin up how many number of instances that you want. You can scale it out however you want.
Okay. Okay.
Maybe that answers your question.
Okay. I hope Sagar you got your answer, or else you can ask. You can unmute and ask if you're having any
Please.
other doubts having.
If I'm not clarifying your doubts, well, please feel free to
Yeah.
ask a follow-up
Sagar,
question.
it's clear, right, Sagar?
Yes.
Or else
Clear. Thank you.
or else you can ask anything if you have any doubt.
So, like for day-to-day activities, we generally work with EMR only, right?
Yeah, day to day. I mean, again, like there are some flows we still run on Glue, but yeah, I was mentioning right that we do some data quality checks and all. So those are not too heavy. After that, actual data loads are done, we do it using Glue, so that we need not maintain too much of a pipelining for orchestrating our jobs. Glue has like everything, right? It has its own scheduler, it has its own monitoring, it can publish everything. So that's where we prefer
So
Glue there.
for data quality checks, so we go with AWS Glue, and for data processing, we go with EMR.
Yeah, with the amount of skill that the amount of data that we have, but Glue can do both of them if you have like limited data that can fit into Glue use case.
Okay.
Can even Lambda functions can do that?
Lambda functions may not be always, because Lambdas has some strict runtime runtime limitation, right? They can run up to 15 minutes if I'm not wrong, whether this has increased in latest releases. But Lambda has 15 minutes of runtime, and the service offered by distributed computing, like the amount of CPU capacity or the space, you can attach your elastic block storage EBS to the EMR again, which will offer you like a lot of RAM for processing huge data sets. I don't think Lambda can fit into that use cases. If you have some minimal triggers, like just calling other service, or fire and forget kind of operations are there, Lambda should be a better use case. But definitely for data processing and all. And one more downside of Lambda is you can't use any of these big data frameworks again. Like you can't use Spark, Hive, or these things. So you should be completely relying on the Python metadata and Python file processing, which is not suitable for big data workloads.
Okay.
Thank you.
That's a cool answer. Okay, Siddhartha. There was one more question from Tejas. He was asking that do you use Lambda functions? How much coding you do in day-to-day work? What kind of coding specifically you do daily?
Okay, that's a good question. Yes, we do use Lambda functions. So yeah, we have some services, as I'm saying, like we create some Python operators in Airflow and all, right? Those would be ultimately preparing a Python file and being executed by Lambdas only. How much coding do you do in a daily day-to-day work? That is a tricky question. So it's all, for example, if you are in, we execute multiple projects parallelly. There is, uh, you know, timeline depends on the timeline. Like most of the part goes in data analysis and data validation itself, setting up these frameworks. So validation is kind of 80% activity, and coding would always be less for data engineers. But after of late, what I'm observing is like we are also coding too much in Python for setting up airflow pipelines, and most importantly, like I've been coding in TypeScript for last 6 months to set up all my infrastructure on AWS accounts using CDK. So yeah, on a day-to-day life, I think from last 6 months I'm coding daily. May not be pushing it to the production, but yeah, trying to code daily.
It's cool. Okay. Anyone? Any more guys? Any more questions? Anyone having any doubts? You can raise your hands and you can ask.
Can you give some insights on CloudFormation?
Sure. So CloudFormation is another AWS service where you can provide your template. For example, if you're already aware of AWS, so you can go to console and do any operation. You can go to console and create an S3 bucket. You can go to console and create a glue job, or try to set the EMR configuration and spin up that. But where CloudFormation comes in handy is if you want to make a CI/CD pipeline for all the infrastructure that you are creating. So it's basically a service which can turn your code into infrastructure, where maybe it is infrastructure as code. You write your whole template. You can choose choice of your language. You can write it in Python, Clouds, TypeScript. So, and if you are too much interested, you can write in YAML files also. End of the day, it will be converted into YAMLs, and it will pass those templates to CloudFormation, which will parse it, and based on your configuration, hey, an S3 bucket needs to be created with this name in this region, with these configurations of intelligent tiering, and with this configuration of bucket properties, and all those things. So you code it, and CloudFormation is a service which converts that code into infrastructure for you within the AWS account.
Okay. Okay. Good. That's cool answer. So, Siddhartha, there was one more question. Like Ashwat was asking that where do you write your code? Either in IDE and submit in EMR, or else writing entire code in EMR, he was asking.
Okay. We write code in IDs basically. So inside Amazon, the development is like very tricky. So you spend time figuring out how to develop rather than actual development. So yeah,
Which
as I
IDE
was
you use
mentioning,
basically?
I personally use VS Code, but people more tend to use JD
IntelliJ.
because we have IntelliJ. We have enterprise licenses and all right inside companies. So they can use IntelliJ. Yeah. Once you push your code to, so we again maintain internal, every service is internal here. So we again maintain internal Git from where it will transport your code to AWS accounts. And at the end of the day, that will be converted into CloudFormation templates and deploy your architecture onto the AWS accounts. So similarly, same for EMR as well. You code your configuration. So EMR offers several APIs. If you want to take a look at EMR APIs, you will see create EMR cluster where you need to specify everything, like you want to create an instance type, all those things, and you pack that API payload and put it in your Python file whenever that is called via Airflow. So it will spin up an EMR for you.
Okay, that's a cool answer. So there was one more question, Siddhartha, from Subhash. He was asking which methodology you follow, Agile or Waterfall. He was asking.
Waterfall. I'm a bit doubtful it exists inside Amazon. So far I have seen like, yeah, it's all agile. Agile is a short word again. It's too agile. We should say, like we decided yesterday and we implement today and change it tomorrow. It's always working backwards in Amazon. You start start based on your requirement and work backwards. the requirements can change at any time. I know this is a big trouble, but yeah,
Okay.
we need to deal with it.
Okay. There was one more question from Sagar. He was asking that whether big data is a replacement of data warehouses. Like more warehouses.
Big data is replacement of warehouses. Sorry, I didn't get this question properly.
No, he was asking that like this big data is there right now. So big data is a replacement of data warehouses. He was asking more specifically.
But data warehouse is basically where you maintain all your
Data.
data. Either
Exactly.
might be for OLAP or OLTP, right?
Exactly.
But big data in a term, maybe it mostly pack of all the technologies that
Exactly.
used to
Including
read, write,
including the
and
data warehouses.
yeah.
Yeah,
So
that's cool. Okay.
yeah.
Any doubts, guys? Any more doubts from the audience? Okay, there was one more question. Do you use Snowflake as a part of your project?
No, we don't.
No, no.
Yeah.
I think they don't use Snowflake as a part of project. Okay.
Yeah.
Okay, guys. Anyone any doubts apart from that? So you Subhash from Subhash. Subhash is asking you do use any Databricks? No, right?
No, it's always internal services because we have EMR, right? So we don't want to compete against our own product, obviously. If internal users are not using, so that is third-party products are not recommended. Maybe not only in Amazon. Like if you take any big MNCs, they always tend to build their own products, thinking of long-term strategies. So third-party products are maybe if it is like, for example, Oracle is there, so it's a leader in that space. Like nobody can match that in financial systems over there. So there is no alternative for that anybody to come and adopt that. So yeah, those kind of technologies you can avoid, but yeah, wherever there is an alternative, it's always preferable to use internal technologies, at least at our scale.
Okay. Okay. Any doubts, guys? Anyone? Okay. So a small doubt from my end, Siddhartha. Let's consider if someone wants to enter into data engineering, what would be your suggestion that what he should pick, which cloud service he should pick? More specifically, he should go with AWS, or else he should go with Azure, or else he should go with GCP. More specifically. So what's your opinion on that?
As far as I remember, if you look at the market capture, so I think Azure for sure is growing rapidly, but the market captured by AWS is beyond everything, right? I think it's more than 40% of the market share. The single cloud is captured. So yeah, so depends on that, but I guess it's hand in hand now. Maybe at least in India, I think the calls are same. But yeah, maybe being loyal to my company, I would suggest AWS.
And AWS is mandatory when you go for like when you're looking when you're going for USA more specifically. And most of the cases I've seen that Spark with AWS, Spark AWS. This is a combination which is more famous across the industry when it comes to particularly USA. So that is what actually I was seeing as a tutor as well. I was seeing that combination. It's a very famous combination over the market as well. So that's cool. And there was one more question, Siddhartha, Lakan was asking. So he was asking that how Redshift differ from S3.
Sure, but where are all these questions coming from? They are pinging me personally. I don't see them in the chat.
No, they are just pinging me directly. So so they are yeah.
Cool. So Redshift is, as I spoke earlier, this is like petabyte scale data warehouse, which can store data, process your data, and mostly used for analytical purposes. Because IO during read write might be slow, but during select it is super fast. It outperforms every other market competitor in that space. So how it differs from S3? S3 doesn't have any compute to process your data. For example, if you store your data on S3, S3 is S3 as an entity is a super cool product where you can dump everything and store whatever the type you want. But Redshift, you can't store everything. It doesn't allow you to store images or videos right away. S3 can does that. Redshift has compute, S3 doesn't have. But both of them working together is a deadly combination. Inside Amazon, or maybe if you have too much of volumes of data that you wanted to keep it in S3 to reduce your Redshift operational cost or burden, and the size of your Redshift cluster can also be diminished if you store the data in S3 and access it via Redshift. Redshift has that connectivity, a special service inside Redshift called Redshift Spectrum to access data
RDS.
from, no, not RDS. Redshift Spectrum
Okay.
is there as an individual entity inside Redshift, which can access data from S3, and it bills you based on the TB, maybe $5 based on the amount of for every TB that it scans from S3. So if your selection is less over the period of time, and if you want to reduce the storage costs over processing costs, it would be a better option to put everything on S3 and read it via Redshift.
Okay.
May
that
I
was
ask a
cool.
question?
Yeah, you can ask.
Yeah, please.
Siddhartha, you said during the course of your talk, you said that you maintain your data pipelines. Can you please throw some more light onto that in detail?
Yeah, sure. So again, I'll get back to that huge table example where we collect data from multiple data sources from the upstream. There would be one team handling all the payments. There would be one more team handling all the shipments. Our job might be getting those two data sets and unite it at our accounts. So there are several sources that we consume data from. One would be from other AWS accounts. We use services like S3 cross account access, which is a very easy service where you can where others can share your credentials to hit that S3 location and get the data. Other might be the lake formation route, where people can give you a governed access via lake formation, and your tables can your services in your account can assume that role and consider the data. So these are some ways. But coming to your question more specifically, internal to Amazon, there are a lot of services where you can put your data in pool. For example, if I wanted to share the data with 20 teams are downstream, 20 teams are doing some 20 different operations using my data. So I have a service internal to Amazon where I can come and put my data into that pool, where everybody subscribes it to their accounts and can be used from there. And there is one more tool, maybe you must people might be aware of this service called Informatica, where you can configure clusters and read the data from there. So yeah, kind of ETL tools also we have internally where you can hook on to any Redshift and get this. So all these are different sources, but to maintain a pipeline, there is again internal services like a distributed job scheduler, where you can schedule any of the jobs, to create individual tasks and bind all of them together to make a flow. And of late, we are migrating too much into native AWS, which is like doing everything on your AWS accounts. So that's where we are using Airflow. Airflow can also connect into any other services. It's end of the day calling Python APIs. So it can connect into all those data sources and make a graph to make the dependencies of every pipeline. And at the end, you will have your ETL process.
Okay.
Okay, thank you. Also, I would like to know if Amazon has any service equivalent to that of Power Apps. Power Apps is very famous these days. That's a Microsoft product, right?
Oh, sorry, I'm not aware of Power Apps. Sorry
Okay, fine, no problem. Thank you.
Yeah.
Okay. That's cool, Siddhartha. Thank you. You you are given a lot of good insights for the people over here, and it was really very nice speaking to you. And almost like anyone having any doubts, guys, apart from this, or else we'll try to wind up this session. Okay, then, guys. Thank you.
There is
Yeah,
And
thank you. Thank you,
Siddhartha.
Siddhartha
Thank you,
and
Siddhartha. Really,
Karthik.
really, it's pleasure that you accepted, because like Amazon means, like Amazon data engineer is coming means there's a lot of excitement here. Like I was so excited that firstly I thought that whether you will accept my invite or not. I was thinking that. So really, it's a pleasure for me. Basically, you have come over here and given a lot of insights for us. So thank you for accepting really, Dada, and thank you for being patient and giving answers very patiently. Thank you, thank you, Siddhartha.
no worries. No
Thank
worries.
you.
Pleasure was mine. Yeah, you're doing a great work. Keep it up, Karthik. And
Thank you.
I'm glad that I contributed a bit of it.
Yeah,
Thanks
thank you.
everyone for
Thank you,
joining.
sir.
Have a good day.
Thank you. Thank you.